now we come to identify and construct constitutional isomers, chain isomers, positional isomers, and functional group isomers. Okay, so before we begin, I want to ask a question. Do these structures have same or different arrangement? Which pair is the isomers of C5H10? Okay, now let us look at the first pair, the blue color. Okay, so let's look at this. We have 1, 2, 3, 4, 5. Okay, this one we also have 1, 2, 3, 4, 5. Okay, in terms of the number of carbon and hydrogen, it is correct, but they are not isomers. Okay, why? Okay, it is because this one is a substituent. So when that we have substituent, it will get lower number. So the substituent is at carbon number 2. Okay, if we look at this one, 1, 2, 3, 4. Because the substituent, we also will give the lower number. So these two structures are actually the same. They are not different. Okay, next one. It is also not isomers. Okay, let us look at why. Okay, 1, 2, 3, 4. Okay, students will consider this as a substituent. 1, 2, 3, 4, 5. This one is a linear chain. Actually, 2A is also linear. Okay, why? One, 2, 3, 4, 5. It is exactly the same. So these 2A and 2B are not isomers as well. Okay, however, 3A and 3B are isomers. Okay, let us look at why. 1, okay, let's look at the substituent first. The substituent will get a lower number. 1, 2, 3, 4. Okay, there's a substituent here. And then if we look at here, 1, 2, 3, 4, 5. So this is linear. This one has the chain is different. This one has one branch. This is the linear. This is the branch. So both of them are different, but they have the same molecular formula. So they are isomers. Okay, so the first one that you need to know is, are they isomers or not? Because many students tend to draw many structure, but actually they are the same. Okay, now let's look at other example. Okay, they are the same. Okay, why? Same thing, there's a double bond here. This is a functional group. When functional group, we give them the lowest number. So it starts from number 1. If you draw the double bond from right hand side, it is also carbon number 1. It is a linear chain, so they are actually the same. Okay, another one that has a functional group of hydroxyl, OH. Okay, so if we hydroxyl, the OH will get the lowest number of carbon. So 1, 2. If it's from right hand side, it's also 2. So they are the same. Okay, now next one is a benzene ring. You can see here there's a double bond, but here there is no double bond. But actually they are the same. When you label all the number, you will find out that the carbon is actually at the same number only. So they are the same. Okay, now another one. This one is on the left. This one is on the right. But still, we consider they are at carbon number 1. Okay, now we look at something different. Okay, for example, aldehyde and ketone. Aldehyde, the carbonyl group must be at carbon number 1. Then ketone must be between 3 carbon. So carbonyl is at carbon number 2. And you can see here, the carbonyl is attached to carbon. So these two are different. Okay, another one is carboxylic acid and ester. Carbonyl, C double bond O, I wouldn't say carbonyl, it's C double bond O must be at carbon number 1 for carboxylic acid. And you can see it's attached to OH. Okay, if for ester, the oxygen must attach to at least one more carbon. And you can see here is carbon number 2. So these two are different. So they are isomers. Now, I just want to highlight what do you need to label for chain isomers or the isomers. Students can draw the isomers, okay, easily. You always start with the longest chain, then shorten it, then add branch. Shorten it, add more branch. Okay, students always tends to forget about label chain isomers. Okay, another one is positional isomers. Students can draw the positional isomers, but they tend to forget the label positional isomers. Okay, next one is the same thing, functional group isomers. Okay, must label as well. Of course, functional group isomers, you know that they totally have different functional group, although they have the same general formula. Okay, now come to this question. Draw all the isomers of C5H10. Okay, when you look at C5H10 homologous series, you know that it is alkene. And then another one, it is cycloalkene. Okay, so my first step is I usually draw chain isomers. Okay, chain isomers means your position of double bond or your functional group cannot change. Okay, for example, here is carbon number 1. So don't change it. Okay, carbon number 1, carbon number 1, carbon number 1. Okay, then you change the position of the substituent to become chain isomers. Okay, second, I will continue with positional isomers. Okay, same thing. Positional isomers do not change the shape of your structure. Only change the position of the functional group. Okay, so you can see F and G, they also have the same shape. That is substituent at carbon number 2, but they only change at functional group. One is carbon number 1, one is carbon number 2. Okay, then finally I will go to functional group isomers. Okay, functional group isomers, you must draw a pair. That is, you must show alkene. Okay, no matter which alkene you can use. And then another one is cycloalkane. The cycloalkane also include the one that has only 4 carbon cyclic and 3 carbon cyclic. Okay, after that, I will write the answer. Okay, you see, I didn't write all the answers. Okay, because some of the structures are the same. For example, A and D are the same. So I just choose A. Okay, so after you draw all of them, find out which one is the same, then you can just cancel out. Okay, this one is in my notes. I just want to clarify how to read them. Okay, for example, this one is not the sign of equals to. This is the sign of double bond. Okay, the double bond O here. Okay, so double bond O is at carbon number 1. Then linear means here 5 carbon, 1, 2, 3, 4, 5, no branch. If here I write 4 linear, 1, 2, 3, 4, one branch at carbon number 2. Okay, this is carbon number 2. Okay, so another one, this is for aldehyde. Another one is for ketone. Okay, and you can see as well, because this is chain isomer, is from linear become branch. Okay, so that's all for this part. Just remember to label, is it chain isomer? It must be first, when you draw isomers, must be at least one pair. Okay, another one, label, is it chain, positional, or functional group? That's all for this part.